All right, I'm going to quickly go through a one sample um, t interval for means. And here's an example of that. There are many ways to measure reading ability in children. Research designed to improve reading performance is dependent on good measures of the outcome. The frequency used test is the DRP, which is degree of reading power. Research selected the mean score of all third graders in Henrico County schools is different than the mean, which is 32. And so this kind of goes into a little bit of hypothesis testing. And so if we have our hypothesis test, we could say that we suspect that the null hypothesis is that the mean actually is equal to 32, and we're trying to figure out our alternate hypothesis. All right, is our mean not equal to 32? All right, we're going to try to figure this out. And we're going to use a confidence interval that maybe help us do that. And so that's a little bit extra. So if you're not in hypothesis testing yet, but that's essentially what we're looking for. And so the distribution of scores is summarized in the mean tab below. So here's our mean of this sample. Here's our standard deviation of the sample. Here's our min, and so on and so forth. So we're going to construct a 90% confidence interval to estimate the mean DPRP score in Henrico County schools. All right, so the first thing is we want to state what we're doing, or our parameter, and our confidence level. All right, so we want to estimate at 90% confidence that the true mean DRP score for all third graders in Henrico County. That's what we're trying to do. Okay. So what we're going to use, all right, is we are planning on using a one sample, all right, t interval for means, and make sure you have your conditions. Okay. So these are our conditions. Our conditions are, is this random? Yes, it's SRS 44 counties. Is it independent? Well, 10% condition would state that 44 is less than 10% of all third graders. Approximately normal, yes, the central limit theorem, 44 is definitely greater than or equal to 30. Okay, so all our conditions are met. So now let's go to the do part. In our do, we're going to take our mean, all right, our sample mean, and we're going to add and subtract that to our margin of error, which is, in this case, our critical value of t, because we do not know what the actual standard deviation of this population is. And so that's why we're using t. All right, whenever you do not know, all right, that, all right, the parameter standard deviation, all right, do not know, then use t, and that's why we're using this. So if we did know that, then we would take and just use a z-score. But we do not know it, and so then we're going to use t. All right, so from there, what we're going to do is we're going to take this standard error, which is our standard deviation. So we're going to take our standard deviation of our sample, divided by the square root of 44. All right, and so when you do that, all right, standard deviation of the sample, 1.19, divided by the square root of 44, you get an answer of, all right, 1.68, and we'll just go 1.69, all right, 1.69, and we'll do that. The thing is, now we need to figure out our t value. So our degrees of freedom is 43, and how do we get that? We take 44 and value minus 1. And so we're going to go to a t table, and we're going to go down here. And this is a t table. I don't have 1, 2, but these are our degrees of freedom. And if you go down here, you notice that we do not have a degree of freedom of 40. So now, or 43. So we're looking for degrees of freedom 43. So it's between these two right here. And so the question is, what do we use? Do we use the higher one or lower one? Well, since we want to play always the safe side, our standard deviation would actually decrease if we add more. So we actually want to go to the lower. We always want to round down. We always want to round down. And so we're going to go to 40. All right, so always round down. Okay, always round down because we want to have the lesser of those values, the lesser of those values, all right, when we're doing it. Okay, and so if we go over here, we can see this is 90%, so we're going to go at this value right there, 1.684. So we're going to bring that up, 1.684, and that's going to be our t value, our critical value, 1.684. And so we're going to take that times 1.684 plus and minus 35.09. Okay, so do that. Okay, and 35.09 plus, all right, maybe I'll just take this 1.684 times 1.69, and I have a value of 2.85, all right, which will go 2.85 plus or minus 35.09. All right, so now we're going to take that value and we're going to find our two different intervals. So 30.09 minus 2.85. And so I have about 32.24 for my lower end, and my upper end, 0.09 plus 2.845. All right, and what I have is 37.94. All right, so that's our confidence interval. That's our 90% confidence interval. And so we're going to interpret this confidence interval. And so what we know is we are 90% confident that the true mean DPR score of all third graders in Harrigan County is captured on the interval 32.24 to 37.94. Okay, so that's what we know. And so we can answer the second question, which is a kind of our hypothesis. So do we accept the null or do we reject it? Well, use the confidence interval to construct and comment on whether you agree with the research's claim. Well, the claim by the researchers is that Harrigan County Schools is different, that the DPS score is different than the national average, which is 32. Is 32 on the interval 32.24 to 37.94. All right. Now the question is that on the interval? Because if yes, we do not have evidence to support their claim. All right. So really, if it is in between this interval, then obviously 32 could be plausible. Okay. So it wouldn't be different. All right. Not different. But if no, which it appears it is right here, so 32 is not on this interval. So that means no. If no, so then what we have is we do have evidence to support the claim because, now we just put this in here, because, all right, 32 is not on the 90% confidence interval. All right, and so we would accept the alternative, and we would reject that. That essentially that Henrico County has the same. That Henrico County is different. It has a DPR level that isn't different. All right. Okay. Well, I hope that helps you out. You might want to maybe just try this on your own. I probably should start with that, but just remember going through the process of state, all right, your parameter and your confidence level, your plan, state what it is, and your conditions, always check your conditions, the do, find your confidence level, and always interpret, and that can help you make some inferencing, all right, regarding some either hypothesis testing or just inferencing about a claim. All right, well, I hope this helps you out. Good luck and God bless in the rest of your problems.